Tonight, we're going to explore the moment that nobody talks about. Every conversation about generation ships focuses on the launch, the engineering of keeping thousands of people alive across centuries, the psychology of people born into a mission they didn't choose. But nobody talks about the other end, the arrival. What actually happens when a ship that left Earth 300 years ago finally reaches its destination? What happens to the people who have spent their entire lives inside a closed metal world, who have never felt real gravity, never seen a sky, never stood on ground that wasn't engineered, who now have to land on a world no human being has been before? By the end of tonight, you're going to understand what arrival on a generation ship actually demands of the people who survive long enough to reach it, and why 300 years of preparation still might not be enough. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now, let's begin. Picture this. You are 23 years old. You were born on a ship. You have never breathed unprocessed air. You have never stood under a sky that stretches to a horizon you cannot see. You have never felt rain. You have never seen a tree. You have never seen a star as anything other than a fixed point of light through a porthole, because that is all they have ever been, points of light, remote, unchanging, irrelevant to the daily business of keeping a vessel functioning and its population alive. Your grandparents were born on this ship. Their grandparents boarded it. 14 generations ago, a group of people made a decision on a planet called Earth. A planet that is nothing to you now, but stories and data files and images your ancestors recorded before the engines ever fired. And they pointed a vessel at a distant star, and they left. They left, knowing they would never arrive. They left so that you could. And now, the instruments are reading something none of your ancestors ever lived to see: the destination. The star on the approach vector has a planet around it. Not just a star, a world. The journey is almost over, and nobody on board has any idea what to do next. Not really. The protocols exist. 300 years of mission protocols, updated and refined by every generation that lived and worked aboard this ship, all of it supposedly preparing for this moment. But a protocol is a document, and a document cannot prepare you for the moment the thing you were told your whole life was coming finally comes. Before we talk about the arrival, we need to understand what was chosen as the destination and why. The star the ship has been traveling toward for over 300 years is called Proxima Centauri. It is a red dwarf, the closest star to the Sun, sitting 4.24 light-years from Earth. That is just under 25 trillion miles. In 2016, astronomers on Earth discovered a planet orbiting Proxima Centauri in what they called the habitable zone, the region around a star where liquid water could theoretically exist on the surface of a rocky world. They named it Proxima Centauri b. It is roughly Earth-sized. It completes one orbit of Proxima Centauri every 11.2 Earth days. On paper, it was the most promising candidate humanity had ever identified for a destination beyond our solar system, a real planet at the right distance around the nearest star. That discovery, made by scientists staring at spectrographic data from a world 4 light-years away, changed the entire trajectory of the generation ship program. It gave the program something it desperately needed: a specific address. A destination that wasn't just a star on a chart, but a world. something to aim for that wasn't purely theoretical, something that might, when you finally got there, be worth the cost of getting there. And so, the plan was made. The ship was designed over decades, built over more decades, crewed through an extraordinary selection and training process that spanned generations on Earth before the first candidate ever boarded. The people who launched were volunteers. Volunteers who understood, as clearly as any human being has ever understood anything, that they would not arrive. Their children would not arrive. Their grandchildren might not arrive. But eventually, if the ship held, if the systems held, if the social fabric of a civilization built inside a machine held together across centuries, someone who descended from them would look up and see a planet growing larger in the senses. And they volunteered anyway. That is not a small thing. That is, in fact, the most remarkable thing about the entire mission. Not the engineering, not the physics, the decision. The moment 14 generations ago, when real human beings looked at everything they had, everything they were, everything they loved, and said, "We will give all of it for something we will never live to see." And they meant it. And they did it. And now, their 14th generation of descendants is in orbit around Proxima Centauri b, and the planet is real, and nobody is ready. Here is what most people get wrong when they imagine a generation ship arriving at its destination. They picture it like a ship pulling into a harbor. The hard part is the crossing. Once you arrive, the ordeal is over. You step off, you breathe the air, you begin your new life. That image is almost entirely backwards. The crossing is brutal, yes. 300 years of recycled air and recycled water and recycled everything. 300 years of births and losses and politics and breakdowns and repairs and emergencies that were solved by people who had nothing to work with except what they had brought and what they had learned. 300 years of watching the star you came from fade to a point indistinguishable from any other point, while the star you're heading toward grows imperceptibly brighter year by year, decade by decade, generation by generation. 300 years of living inside a machine in the dark between worlds. But that machine is designed for exactly that. It is built to keep people alive in a vacuum. It has walls. It has atmosphere. It has food systems, warmth, gravity, redundancy upon redundancy upon redundancy. The people aboard know how it works. They have spent their entire lives mastering it. They know every duct and every seal and every backup system. When something breaks, they fix it. They know how to fix it because they were taught by people who learned to fix it, who were taught by people who designed it, whose notes and diagrams and troubleshooting logs are stored in the ship's archive and have been consulted countless times across 3 centuries. The ship, over 300 years, has become almost an extension of the crew. Not a vehicle they are passengers on. A world they understand completely. And then they arrive. And everything they know becomes not useless exactly, but insufficient. Because a planet is not a ship. A planet does not have systems they understand, or engineers they trust, or repair manuals they have memorized. A planet is a foreign environment with its own atmosphere, its own gravity, its own chemistry, its own biology, its own history of geological and climatic and radiative events that have been happening for billions of years without any consultation with anyone. The challenge doesn't end at arrival, it transforms. It becomes something entirely different, something far less predictable. something that cannot be fully managed by following a protocol. Because the protocol was written by people who had never been there. And there, it turns out, is not what anyone expected. Not quite. The first thing that has to happen before anyone touches the planet is observation. Serious, methodical, patient observation. The ship carries instruments for exactly this. Spectrometers, to analyze the composition of the atmosphere and determine whether it poses any immediate chemical hazards to human biology or to suit materials. Thermal sensors to map surface temperatures across different regions and across the boundary between the permanently lit and permanently dark sides of the planet. Radar and high-resolution imaging arrays to build detailed topographical models of the terrain, to identify stable landing areas and to flag potential hazards. Biosignature detectors calibrated to look for the chemical and spectroscopic signatures associated with biological activity, past or present. Chemical analyzers to characterize the soil and any surface water, and to assess what would need to be done to make either of them usable. This process takes months, maybe longer. The people on the ship, who have been traveling for 3 centuries, who are finally close enough to see the surface of the planet with their own instruments in real time, have to wait. They have to study. They have to be methodical in a way that feels almost impossible after everything it took to get there. Because the planet is not going anywhere. And making a catastrophic mistake in the first weeks of surface contact could destroy the mission. Not damage it. Destroy it. There is no resupply. There is no backup crew. There is no agency on Earth that can dispatch a rescue in any time frame that matters. If the first surface team walks into a chemical hazard that their suit materials are not compatible with, and they go down before they can make it back to the lander, the loss is permanent. The crew that remains on the ship will grieve, and they will learn from it, and they will proceed more carefully. But they cannot replace what was lost. This is the context in which every decision in the arrival phase is made. Not fear, exactly, but a precise, clear-eyed understanding of what mistakes cost here. And so, they observe, and they wait, and they build models, and they argue about what the data means, and they revise the models, and they argue some more. Because the people who are going to walk on that surface first want to know exactly what they are walking into. And they will not go until they are as certain as the data allows. Here is where the science of the destination becomes essential, and where it becomes deeply complicated. Because Proxima Centauri is not like the Sun, not even approximately. It is a red dwarf. Red dwarfs are the most common type of star in the Milky Way, by a large margin. About 7 out of every 10 stars in the galaxy are red dwarfs. They are smaller, cooler, and far dimmer than the Sun. Proxima Centauri has about 12% of the Sun's mass. Its surface temperature sits around 5,000 degrees Fahrenheit, or about 2,760 degrees Celsius. Compared to the Sun's 9,900 degrees Fahrenheit, or about 5,500 degrees Celsius. Where the Sun is yellow-white, Proxima Centauri glows a deep, dull red. Its luminosity is only about 0.0017 times that of the Sun. It is, by the standards of the Milky Way, a very ordinary star. Unremarkable in almost every respect, except that it is the closest one to us. And it burns so slowly, so efficiently, on such modest fuel reserves relative to more massive stars, that it will remain in its current state for roughly 4 trillion years. The Sun has about 5 billion years left before it exhausts its hydrogen fuel and begins to change dramatically. Proxima Centauri will be burning long after the Sun is gone. Long after the solar system, as we know it, has ceased to exist in any recognizable form. In some ways, red dwarfs sound like excellent hosts for habitable planets. Long-lived, stable, over geological timescales that dwarf anything available around a more massive star, common enough throughout the galaxy that if life can arise around them, the universe is densely populated with potential habitats. But Proxima Centauri has a problem, a significant one. And the crew of the arriving generation ship has been studying this problem for their entire lives, in preparation for exactly this encounter. Proxima Centauri is a flare star. Violent, sudden eruptions from the star's surface release enormous bursts of ultraviolet radiation, X-rays, and streams of energetic particles. These flares happen without reliable warning. They can occur multiple times per month. They can dwarf anything the Sun typically produces over a comparable period. In May of 2019, astronomers on Earth recorded one of the most powerful stellar flares ever observed from a red dwarf. A burst of ultraviolet radiation so intense that if Proxima Centauri b has an atmosphere similar to Earth's, that single event would have increased the ultraviolet radiation at the planet's surface by more than 14,000 times normal levels for a brief period. 14,000 times. A factor of 10 above normal would be enough to cause serious damage to unprotected biological tissue and to degrade unshielded surface equipment. 14,000 is not an unusual variation. It is a catastrophe for anything hoping to exist on the surface without significant shielding. And this is not a one-time event. Proxima Centauri flares regularly. Some studies suggest multiple significant flare events per month. The planet orbits very close to its star, at approximately 0.05 astronomical units, completing one orbit every 11.2 days. This close distance is why it sits in the habitable zone, despite the star's dimness. But that close orbit also means the planet is exposed to intense stellar radiation, particularly in the high-energy wavelengths that break apart biological molecules and strip atmospheric gases from planetary surfaces over geological time. The question of whether Proxima Centauri b has retained a thick enough atmosphere to provide meaningful radiation protection at the surface is, as of the generation ship's arrival, still not fully resolved by the orbital survey data. The instruments are working on it. The models are being refined. The crew needs the answer before they put people on the ground. And layered on top of the flare problem is something else. Something that has no equivalent in any human experience of planets. Proxima Centauri b is almost certainly tidally locked to its star. At that orbital distance, around the gravitational influence of a star of this mass, tidal forces would have slowed the planet's rotation and locked it long ago. One face permanently toward the star. One face permanently away. No rotation. No day-night cycle. The day side sits under a red sun that never moves. Never rises. Never sets. Just hangs in the same position in the sky for the entire age of the planet. The night side sits in perpetual frozen darkness. Cold enough in the extreme regions that certain atmospheric gases may have condensed and fallen as frost. Between them, the terminator line, the boundary between day and night, a ring of permanent twilight that encircles the planet. where the sun is always just above or just below the horizon, where the sky is always in that state of transition between full light and full dark, where temperatures, according to the best models the crew has, are the most moderate on the entire planet. This terminator region is where most of the accessible water signatures appear in the orbital data, where the atmospheric conditions are most likely to be tolerable for suited surface operations, where the geological activity, concentrated around the thermal gradient between the two hemispheres, produces the most interesting and potentially accessible chemistry. This is where the settlement has to go. A strip of permanent twilight on a tidally locked world orbiting a flare star, 4.24 light-years from Earth. It is a thin margin, but thin margins are still margins. And the crew has survived on thin margins for 300 years. The atmospheric analysis from the initial orbital survey and the first wave of probe data takes 6 weeks to process into a usable picture. The results are complicated. Not catastrophic. Complicated. The atmosphere of Proxima Centauri b is thin. Surface pressure approximately 30 to 40% of Earth sea level. This is the first major constraint. The atmosphere is not directly breathable by unprotected humans. Not because of oxygen percentage, which is actually detectable if lower than Earth's, but because the total pressure is insufficient for human respiratory physiology. Breathing the outside atmosphere unassisted would be like being at an altitude on Earth, where the air is simply too thin to sustain consciousness, no matter what its composition. The atmospheric composition includes nitrogen in the dominant fraction, oxygen at a low but measurable level, carbon dioxide in trace amounts, and several compounds that do not have clear Earth analogues. These novel compounds are the ones that demand the most attention, because some of them are reactive. And reactive compounds in an atmosphere mean reactive compounds in every surface environment the crew will be working in. The engineering team takes the atmospheric composition data and runs it against the material properties of every component in the crew's planned surface equipment. Suits, habitat module, seals and gaskets, communication, cable sheathing, sample collection containers, drilling equipment components, vehicle surfaces, anything that will be in direct contact with the outside atmosphere for extended periods. The analysis takes 2 weeks. The answer comes back with a specific concern. 3 material categories show significant predicted reaction rates with a specific compound in the atmospheric mix. Not catastrophic reaction, not instant failure, but degradation rates that would reduce the functional lifespan of affected components by between 50 and 70% compared to their rated specifications, which means planned maintenance schedules would need to be dramatically accelerated, which means the crew would be spending far more time and material resources on component replacement than the mission protocols anticipated, which means they need to either find alternative materials for the affected components, modify the surface operations timeline to account for the accelerated maintenance burden, or develop protective coatings that can be applied to the vulnerable components before they go outside. The engineering team works on this for 3 months. They redesign the outer material layers of the surface suits using compounds from the ship's stores that show lower reaction rates with the identified atmospheric component. They develop a coating process for the most vulnerable equipment surfaces. They update the maintenance schedules across the board, and they build in a period of extended surface testing for the redesigned components before any human goes down relying on them. 3 additional months. The crew watches all of this with the patience of people who have been waiting for 300 years. 3 more months is nothing. 3 more months is being careful. And being careful is what keeps you alive. 412 days after the ship achieves stable orbit around Proxima Centauri b, the first landing takes place. Over a year of patience. Over a year of watching from above. Over a year of probes and sensors and atmospheric models and fabrication and refabrication and testing and retesting. A landing craft carrying 4 crew members separates from the ship. It enters the upper atmosphere. The hull heats as the thin but real atmosphere exerts friction on the craft's surface. The crew inside feel deceleration that is different from anything the ship's rotation produces. Real deceleration. The planet pushing back against them. They feel it in their chests, in the subtle shifts of fluid in their inner ears. They feel the planet before they see it clearly. The craft descends through cloud layers, through atmospheric gradients that their instruments are recording at this altitude for the first time, with direct measurements rather than remote sensing estimates from orbit. The clouds clear. Through the small viewports, through the haze of the lower atmosphere, under the fixed light of a red sun sitting low on the horizon that curves below the terminator line, they see the surface. Rock. Dark, striated, layered rock. Terrain that has never been seen by human eyes before this moment. Mountains and valleys, shaped by geological processes that operated for billions of years without any human observer. Textures and formations that have no exact equivalent in any geological catalogue from Earth, because they formed under conditions unlike anything Earth geology produced. A world. Real and physical and completely indifferent to the people watching it through the viewports. The landing craft sets down. The ground holds. The instruments report atmospheric pressure, surface temperature, radiation flux, all within the parameters defined in the mission protocols as acceptable for surface operations. The crew sits in the lander for 40 minutes, running through every item on the post-landing checklist. Every instrument verified. Every suit integrity reading confirmed. Every seal checked. Every atmospheric sample collected through the external sampling ports and analyzed by the onboard laboratory. 40 minutes. Then the hatch opens, and someone steps out. Think about who that person is. They are 29 years old. They were born on the ship. They have never heard wind except in recordings. They have never felt uneven ground under their feet, except in the gymnasium modules where the floor was deliberately textured to approximate varied terrain. They have never experienced the acoustic difference between a closed room and an open space. They have never seen shadows that move as a light source moves, because the artificial lighting in the ship does not move. They step out in a pressure suit because the atmosphere is not compatible with unprotected human respiration at this surface pressure, and they stand on the surface of another world. The ground shifts slightly under the weight of their first step, not dramatically, not dangerously, but enough that they feel it through the soles of their boots. The surface is not the uniform, predictable floor they have walked on their entire life. It has texture, variation, resistance that changes from one footfall to the next as the regolith compresses differently beneath them. Their suit instruments record everything in real time, broadcasting back to the lander and from the lander back to the ship in orbit. atmospheric pressure at the surface, temperature, radiation levels, and gravity. The gravity of Proxima Centauri b, estimated from orbital mechanics to be somewhere between 0.8 and 1.2 times Earth standard gravity. They feel it. Not dramatically different from the ship's artificial gravity, but different in a way that is below conscious articulation. The way fluid sits in their inner ear, the way their muscles engage to maintain upright posture, the way everything just feels more real than anything they have ever known, because it is more real. It is not simulated. It is not engineered. It is the universe acting on them directly through the mass of a planet beneath their feet, on a world orbiting a star 4 light-years from where their species evolved. They stand there for a moment longer than strictly necessary. The operations center on the ship, watching their telemetry, says nothing. There are things you do not interrupt. And then the crew member speaks, records a note in their mission log, a factual observation about the surface material visible directly ahead of them. And they begin. The first surface team spends 18 days at the initial landing site. Every day follows a structured sequence. Every observation is logged with timestamps and precise coordinates from the satellite navigation network, the ship placed in low orbit months earlier. Every sample is collected from marked positions. Every photograph is metadata tagged. Every instrument reading is associated with the specific probe or sensor that generated it. The data is comprehensive. It is also, inevitably, limited by the fact that they are in one place on a large planet. 18 days in one location is not enough to understand a world. But it is enough to establish a baseline, to learn what normal looks like here, so that when they go to another location and something is different, they will know it is different. The ground is not uniform. The surface material is a regolith, essentially pulverized rock, broken down by billions of years of radiation, temperature cycling driven by the thermal gradient between the hemispheres and whatever atmospheric chemistry has processed it over geological time. In some places, it is loose, fine-grained. In others, it is more consolidated, harder, layered in ways that suggest different depositional histories. The dark striations in the exposed rock faces record a geological history that the crew's geologist spends most of the 18 days beginning to decode. It is slow work. Planetary geology, done properly, takes years, decades, sometimes longer. But even the beginning of reading a planetary record is extraordinary. Each layer of rock in those striations represents a period of this planet's history. Material deposited and consolidated under specific conditions that existed before any human being existed anywhere in the universe. Conditions that were happening when the most complex life on Earth was still single-celled organisms floating in warm, shallow seas. The planet has a history. It had a history for billions of years before the ship arrived. And the crew is just beginning to read it. And that reading will take generations. Their generations. The generations they will raise on this world. The generations who will, in some distant future, have a comprehensive geological understanding of this planet, the way Earth geologists have a comprehensive understanding of Earth. It starts here, with an 18-day initial survey, with one crew member crouched over a striped rock formation, taking photographs from every angle, making notes that future scientists will build on. It starts at the beginning, which is where all things start. The sky above them is dim, red-tinged, dominated by a sun that sits in a fixed position and does not move. This is the strangest thing for the crew to adjust to. Not the pressure, not the temperature, not the alien chemical smell that their instruments register in the external atmosphere. The stillness of the sun. Every human intuition, built from 300 years of artificial lighting that cycled through simulated days and nights, calibrated to maintain circadian health, tells them the sun should be moving. On Earth, the sun rises. The sun sets. The shadows rotate. The quality of light changes through the day. The sky changes color from dawn to noon to dusk. None of that happens here. The sun sits where it sits. The shadows point where they point. The light is constant. And standing in that constant, never-changing, red-tinted illumination, under a sky that grades from dim to darker toward the night side, without any shift or transition that any human being has ever experienced naturally, is something for which no amount of preparation is adequate. You can know it intellectually. You can look at the models and the imagery and understand completely that the sun on a tidally locked world does not move. But knowing it is not experiencing it, and experiencing it for the first time, is disorienting in a way that the crew members struggle to articulate in their mission logs. One of them simply writes, "It does not feel like a sun," and does not elaborate further. And that is probably the most accurate thing that could be said. Because the sun, to any human being who has ever existed, is a thing that moves. It is a reference point. It tells you the time of day. It tells you direction. It tells you what kind of light to expect. It is a clock built into the sky, and this one does not move. And that, more than anything else about the planet's alien nature, sits in the crew members' minds as something to get used to. Something they will get used to. But not yet. Not on day one. The days that follow the first landing are exhausting in ways nobody fully anticipated. Not physically, not primarily, cognitively, because every single thing they observe on the surface requires interpretation without precedent. On the ship, everything is known. Every surface, every material, every process has a history that the crew understands because they, or their parents, or their grandparents, built it or maintained it. When something looks unusual on the ship, there is a reason for it. That reason can be found in the records. There is a record for everything on the ship. On the planet, nothing has a record that the crew wrote. The geological formations. What processes created them? What does the layering pattern tell them about the history? Does it indicate periods of different volcanic activity? Ancient tectonic motion? The deposition of material from a body of liquid that may have existed here billions of years ago. The faint moisture signature in the soil near a particular outcropping, is this evidence of subsurface water percolating upward through permeable rock layers? Or is it a surface phenomenon driven by the thermal gradient between the hemispheres? The strange, repeating chemical signature that the initial probes flagged in soil samples and which the surface team is now confirming in multiple locations at different distances from the landing site. What is it? Is it abiotic chemistry, the product of mineral interactions and ultraviolet and particle radiation from the star operating on a geological timescale? Or is it something more complex? Each question requires time. Real scientific time. Months of analysis, not days. And, simultaneously, The crew does not have months to spend purely on scientific questions before they begin building the infrastructure that will keep them alive. The scientific questions are urgent. The survival questions are more urgent. Both have to be addressed at the same time, by the same people. Everyone is a scientist and an engineer. Everyone is gathering data and building systems in parallel. And everyone is doing it on a planet where the unexpected is not the exception. It is the rule, and they handle it. Not smoothly, not without mistakes, but they handle it, because that is what they were built for. Literally built for over 300 years of generational preparation. There is a question that sits at the center of everything the crew is doing in the early months of surface operations. The most important question in the history of biology. Is there life on Proxima Centauri b? The significance of the answer cannot be overstated. If the answer is no, the mission's ethical framework is relatively straightforward. A crew of people, descended from humans who left Earth, are settling an uninhabited world. They are bringing life to a place that has none. Whatever they build here, they build without displacing anything. If the answer is yes, everything changes. Not in the sense that the mission ends, in the sense that the mission becomes something entirely different from what it was. How you settle a world with existing biology is not a simple engineering problem. It is an ethical problem, a scientific problem, a problem that requires decades of careful study before you can make responsible decisions. And the crew has to navigate this while also, simultaneously, keeping everyone alive. If life exists on Proxima Centauri b, the most likely scenario is that it is microbial. The radiation environment of a flare star is extraordinarily hostile to the development of complex multicellular life on the surface. The extreme climate distribution of a tidally locked world challenges most of the biological complexity we associate with Earth's surface ecosystems. But microbial life is extraordinarily resilient. Earth life exists in volcanic vents at the bottom of the ocean under crushing pressure and extreme heat. It exists in hypersaline lakes where no complex organism can function. It exists in the cooling ponds of nuclear reactors and in the high-altitude ice fields of the Himalayas and inside rocks in the driest deserts on Earth. Microbial life is the baseline, the thing that survives when nothing else does. If life has ever had a foothold on Proxima Centauri b, microbial life is the most likely form it would take. Life that has spent billions of years adapting to exactly the conditions this planet offers. Radiation levels that would be lethal to most Earth organisms. Temperature extremes across the terminator. Chemistry driven by minerals and stellar radiation, rather than by the organic-driven processes that dominate Earth's soil. Life that has built its biochemistry around whatever this planet provides, which may not resemble Earth biochemistry in any recognizable way. This matters enormously for the crew, because if Proxima Centauri b has its own biological ecosystem, even a purely microbial one, introducing human biology to that system is a two-way risk. The crew's microbiome. The trillions of bacteria and archaea and viruses and fungi that live in and on every human body will encounter an alien biosphere. And biology is not predictable at that level of complexity. Earth life encountering completely alien life. Life that evolved in a different star system, on a different planet, with a different stellar radiation environment, potentially using different molecular machinery, is not a controlled experiment with a known outcome. It is an encounter between two ecosystems that developed in complete isolation for billions of years. The results could range from total biological incompatibility, meaning no meaningful interaction at all, to something far more complicated in either direction. The mission protocols say, do not contaminate, maintain biological containment as long as possible. Study first. Understand before you commit. But protocols were written by people who were not standing on the surface of another world, looking at a repeating chemical signature in a soil sample, trying to figure out whether the most profound discovery in the history of science is sitting in a test tube in front of them. And reality sets its own terms. Always. The soil samples from the initial landing site and from probe collection sites distributed along the Terminator are analyzed over 4 months. The results are complicated in a way that is both thrilling and frustrating. The atmospheric chemistry reveals a world that is photochemically active. Proxima Centauri's radiation, particularly during flare events, drives reactions in the upper atmosphere and at the surface that produce complex organic molecules from simpler chemical precursors. This is not unusual. Titan, the large moon of Saturn in our own solar system, has an extraordinarily rich organic chemistry produced entirely by photochemical reactions with no biology involved. The presence of complex organic molecules on Proxima Centauri b is not, by itself, a biosignature. It is expected. It is the universe doing chemistry. But, among the complex organic compounds in the soil, there are several that do not fit neatly into any known abiotic synthesis pathway in the crew's models. Not, obviously, biological. The crew does not find cells. They do not find membranes or self-replicating structures, or anything that unambiguously resembles the organizational complexity associated with life as Earth biology defines it. But they find molecules with properties that suggest they were produced by something that was responding to its environment in ways that simple chemical reactions do not produce. The word that appears most frequently in the analysis logs during this period is uncertain. The crew does not rush to a conclusion. Rushing to a conclusion in this situation would be among the worst decisions they could make. They design more experiments. They deploy additional probes to collect samples from deeper in the subsurface, below the radiation-processed surface layer where any surviving life would most likely shelter. They calibrate their instruments to look for specific molecular signatures that would more definitively distinguish between abiotic chemistry and biological activity. They argue carefully, constructively, in the way that 300 years of closed-system living has taught them to argue, not to win, to find the right answer. And they continue to build, because they cannot afford to stop building while they wait for scientific certainty. Science does not have a delivery schedule, and the settlement has one. The settlement's first pressurized surface module is completed in month 7 of surface operations. It is not large. 8 by 12 meters. Enough for 6 people to live in with reasonable comfort while conducting surface work. The floor is sealed against the regolith. The walls incorporate radiation shielding composed of high-density polyethylene and water maintained in dedicated internal cavities. Water that serves double duty as both radiation absorber and thermal insulation. The airlock is triple redundant. It is the first enclosed, pressurized, permanently staffed human structure on another world outside our solar system. From the outside, it looks like a bunker, which is essentially what it is. A bunker against the radiation and the thin atmosphere and the alien chemistry and the flares that can push the radiation level at the surface to dangerous heights within minutes. Inside, it is small and functional, and nothing like the ship. The ship, despite everything, has 300 years of accumulated human habitation in it. The walls have been repainted dozens of times. The corridors have been widened here, narrowed there, to accommodate changing needs across changing generations. There are marks on the walls where generations of children measured their height as they grew. There are worn patches on the floor where people have walked the same path for 100 years. The ship is a lived-in place. The surface module is not. It is brand new. It smells of fabricated materials and soot sealant and the filtered outside atmosphere that the ventilation system draws in and processes. It does not smell like anywhere anyone has ever been. And the 6 people who spend their first night in it lie in their bunks and listen to the sounds of a building, doing what buildings do, settling, adjusting, managing the thermal differential between the heated interior and the cold exterior, making the sounds of existing. A building on another planet. The water question resolves in month 9. Probes sent to drill into the subsurface along the Terminator reach liquid. The first drilling site finds ice at depth, frozen water, accessible eventually, but requiring significant energy expenditure to melt and process. The second drilling site, 124 miles from the first, hits something different at about 40 meters down, a liquid water lens. A pocket of water kept liquid by geothermal heat rising from below, protected from the surface cold by the insulating rock above it. The probe extracts a sample. The sample is carried to the ship's laboratory in orbit via a sealed capsule on a surface-to-orbit shuttle. The laboratory analyzes it. The water is heavily mineralized. Sulfur compounds at concentrations that would be directly toxic to human biology if consumed without treatment. Dissolved metals in quantities that would damage kidneys over time. A pH significantly lower than neutral, reflecting the specific geochemistry of this planet, billions of years of rock dissolving into subsurface water, building a chemical signature that is entirely this world's own. But it is water, actual water, hydrogen and oxygen, sitting in a pocket under this planet, isolated, for a time that may be measured in millions or billions of years. And for the crew, it is everything. Not because it is drinkable. It is not drinkable, not in its current state, but because it is processable. With electrolysis equipment, it can be split into hydrogen and oxygen. With filtration systems, the toxic dissolved compounds can be reduced to safe levels. With chemical treatment, the pH can be adjusted. The planet has water. Liquid water. Water that can be reached. Water that can be worked with. The crew does not celebrate this in any dramatic way. They log it. They update the resource models. They begin planning the extraction system. And they keep working, because that is what the data demands. And what the data demands, the crew delivers. The process of establishing reliable water extraction takes 11 months. A drilling rig is designed, fabricated in sections aboard the ship, transported to the surface by shuttle, and assembled by crew members working in suits on the surface of a world where atmospheric flows, driven by the thermal gradient between the hemispheres, create conditions the crew has to account for in all surface operations. The rig reaches the water lens. The extraction system begins to flow. The first on-planet water processing facility comes online in month 18 of surface operations. It produces a small stream of processed, drinkable water, not enough to sustain the full surface crew without drawing on the ship's reserves, but enough to demonstrate the capability, enough to reduce the drain on those reserves in a measurable way. The day the first cup of water processed from Proxima Centauri b is consumed by a crew member, it goes into the mission log. The date, the crew member's name, the chemical composition after processing, the temperature, a factual entry in a log that spans 3 centuries of meticulous record-keeping. And then the crew member drinks it. It is slightly metallic in flavor. The mineral processing system has not yet fully eliminated all the compounds that affect taste without being directly toxic. The crew member notes this. Flavor improvement ongoing. Processing refinement required. Estimated timeline for taste-neutral output. 3 additional months of system adjustment. And then they finish the cup and go back to work. They are building civilization, and they are being methodical about the flavor profile of their water supply while they do it. The agricultural challenge begins to take concrete shape in parallel with the water extraction work. The ship has been feeding its population for 300 years on a combination of hydroponic plant cultivation, laboratory protein synthesis, and carefully managed soil-based growing systems using earth biological cultures maintained across generations. This system works in a closed loop with no external resource inputs. On a planet, it needs to expand. The goal, measured in decades, is to establish agricultural systems on the surface that can feed the entire settlement without depending on what the ship carries. The ship's food stores are finite, designed to sustain the population through the journey and through the initial establishment phase, not designed to sustain a settlement indefinitely. At some point, the settlement has to feed itself from what the planet provides. The soil of Proxima Centauri b is not Earth soil. It lacks the biological complexity that 3.5 billion years of life on Earth built into our planet's surface layers. There are no fungi breaking down organic matter into accessible nutrients. No bacteria cycling nitrogen through compounds that plants can use. No earthworms, no complex soil fauna, no biological processing of any kind. It is mineral material. Geochemically, interesting in some cases, surprisingly rich in certain elements the crew needs, but biologically inert. The crew cannot simply plant seeds in it and expect a harvest. They brought soil amendment materials, freeze-dried cultures of the key microbial communities that make Earth agricultural soil functional, organic compounds to provide initial nutrient availability, while the microbial populations establish themselves in the alien substrate. These amendments begin the process of converting alien regolith into something that approaches agricultural soil. But this process is slow. Year 1. Microbial cultures are introduced to prepared beds of amended regolith in the growing modules. The cultures begin to establish, begin to process the mineral substrate, begin, very slowly, to build the first thin layers of biological activity in an environment that has never hosted biology before. Year 2. Cautious test plantings. Small beds of the most radiation-tolerant, nutrient-efficient crops in the ship's genetic library, refined across generations for exactly this application. Some of them fail. Some fail because the soil chemistry is not yet close enough to what they need. Some fail because the light spectrum inside the growing modules still does not perfectly match the specific requirements of each crop variety. Some fail for reasons the crew cannot immediately identify, which means more analysis, more controlled experiments, more patience. A few survive. A few produce. Not much. Not enough to matter nutritionally against the settlement's total caloric needs. but enough to prove the process can work. Enough to iterate from. And the crew iterates. Because iteration is all they have. There is no option that is faster. There is no supply ship coming to fill the gap. There is just the work and the patience to do it correctly, and the accumulated knowledge of 300 years of keeping a closed biological system alive. The power question underlies everything. Water processing requires power. Agricultural lighting requires power. Habitat life support requires power. Fabrication equipment requires power. Medical systems require power. Communications require power. Even the suits the crew wears on the surface require power for thermal management and atmospheric processing and communications. The ship's nuclear reactor provides power while the ship is in orbit. Energy is channeled to the surface systems via shuttle-transported charge storage systems and a direct transmission link from the ship to a receiving array on the surface. But the ship cannot remain in orbit indefinitely. It was not designed for indefinite orbital operation around a planetary body. Its systems age. Its maintenance requirements grow. The population available to maintain it thins as more people move to the surface. And beyond the practical constraints, the ship's value as a vessel becomes secondary to its value as a resource. The metals in its hull, the components of its systems, the material in its reactor housing, all of it is more useful as raw material for surface construction than as a vessel slowly degrading in orbit. The decision to decommission the ship is written into the mission protocols. The people who designed the mission understood that the ship was always a means. Its purpose was to carry the mission to Proxima Centauri b. When that purpose is fulfilled, its highest use is as material. Knowing this intellectually and living through it are different things. The ship's reactor core is moved to the surface in the largest and most complex single operation of the entire mission. 4 months of planning. 3 weeks of continuous work. The reactor is extracted from the ship's engineering section, placed in a transport module specifically built for this transfer, and brought down through the atmosphere on the largest landing craft the settlement has. It is set down in a prepared excavation site 1.2 miles from the main habitation complex, connected to the settlement's power grid, and brought online. And for the first time, the settlement has power that comes from the ground it stands on. Power that does not depend on a vessel in orbit. The ship is then systematically disassembled. Hull panels come down. Structural components are landed. Electronic systems are stripped and sorted and inventoried. Every material that has any use on the surface is brought down. Nothing is wasted. 300 years of accumulated hardware, maintained across generations with extraordinary care, now becoming the raw material of a settlement. The last shuttle flight from the ship carries the final data archive. The complete backup of everything. Every log entry from the entire journey. Every maintenance record. Every birth record. Every record of the gone. Every piece of music someone composed in their off hours. Every story written by someone born in transit who wanted to leave something behind. All of it downloaded and stored in the settlement's archive. And then the ship is maneuvered out of orbit by remote control and sent on a trajectory that brings it to rest on the planet's surface in a location chosen for its distance from the settlement and its geological stability. A final landing, unmanned. The ship touches down, and it is still. There is no ceremony in the protocols for this moment. The designers of the mission understood they could not prescribe ceremonies for moments whose emotional weight they could not predict. But the crew gathers anyway. Not all at once, in shifts, in small groups. At the viewports of the surface habitats, or in the operations center where the telemetry of the ship's final descent is displayed on screens. They watch it come down. Their world. The only world any of them has ever known, until now. The vessel that carried their grandparents and their grandparents' grandparents and every generation between. The machine that kept everyone alive across the void. It comes down through the thin atmosphere, the friction heating the leading edges briefly, and then it is down, and it is still, and its systems go dark, one by one, as the automatic shutdown sequence runs. And someone in the operations center, a senior crew member who has been doing their job for 20 years without any visible display of sentiment, quietly walks out of the room. And nobody mentions it. And they get back to work. Because there is always work to do. And that is, in many ways, the most important thing the ship gave them. The understanding that the work is the thing. That you do not stop. That you do not let the weight of what you are doing become larger than the doing of it. You grieve on your own time. And you work on the mission's time. And the mission is permanent. The settlement grows. Module by module. Tunnel by tunnel. Room by room. The subsurface excavation extends further into the rock as the drilling equipment improves and the geological survey reveals which areas are most stable, most accessible, most naturally shielded by the geology above them. The water processing facility's output increases as the extraction capacity expands and the processing systems are refined. The agricultural beds, in Year 4, begin producing meaningful food quantities. Not the majority of the settlement's calories, but a real fraction. Something that reduces the draw on stored supplies in a measurable way. The crew tracks this fraction obsessively. Each percentage point of local food production is time. Time that the stored supplies are not being consumed. Time bought from the planet. And time, on Proxima Centauri b, is the most valuable resource there is. The medical situation in the early years is manageable but demanding. Radiation exposure on the surface, even in the shielded zones near the Terminator, is higher than anything the crew experienced inside the ship. The suits reduce exposure dramatically. But suits are not perfect shields, and no crew member wears a suit every waking moment. Inside the habitats, the shielding is substantial. But substantial is not absolute. Cumulative exposure for surface crew members is tracked carefully. Rotation schedules limit individual surface time. Medical monitoring is frequent and thorough. The medical team works through the biological effects they observe with systematic precision. Identify, document, analyze, develop a response, implement, evaluate, iterate. The crew's health is the most critical system in the settlement. Everything else can be repaired or replaced with time and resources. The people cannot. Not quickly. Not at this population size. Every person in this settlement is irreplaceable in a way that is literally, practically true. And so the medical team receives resources and attention in proportion to that reality. One of the things nobody fully anticipated about arrival is the psychological impact of natural phenomena. Not the alien ones, the familiar ones. When a flare happens, and the instruments on the surface habitats register the incoming radiation spike, the crew inside the habitats watches the readings climb and waits for it to pass. This is not a new experience. Flare monitoring has been part of the surface operations protocol since before the first landing. The crew knows what a flare looks like on the instruments. They know the shielding holds. They know the protocol. But knowing the protocol is not the same as the feeling of sitting inside a habitat on the surface of a planet, looking at radiation readings that are climbing toward dangerous levels outside, knowing that outside is a real outside, not the controlled vacuum of space beyond the ship's hull, but an actual atmosphere, an actual sky, and that somewhere in that sky, a star is erupting. It is different. Not more frightening, necessarily, but different in a way that takes time to integrate. Because the ship's hull was engineered protection, the habitat module's shielding is engineered protection. But the rock above the partially buried sections of the settlement, that is geological protection. The planet is protecting them. The same planet they are trying to figure out how to live on. That is a strange thing to feel. It is not gratitude exactly. The planet is not doing anything intentional. But it is a different relationship than they had with the ship. The ship was something they maintained, something they kept alive through constant attention. The planet does not need them to maintain it. It has been maintaining itself for 4 billion years and will continue to do so regardless of what they do. And that asymmetry, that realization that they are the ones who need the planet rather than the other way around, shifts something in how the crew relates to where they are. It is more humbling, more grounding, in the literal sense. They are not keeping this world alive. This world is what they need to survive. And that difference matters more than it sounds. It changes how they think about conservation, about resource extraction, about what they owe the planet. Not in a sentimental sense, in a very practical sense. The planet's geological stability, its water resources, its atmospheric chemistry, even its radiation environment, all of it is the foundation of everything the settlement is built on. If they degrade it carelessly, they degrade the foundation of their own survival. The mission protocols address this. They always have. Sustainable extraction practices were written into the operational guidelines before the ship left Earth. But there is a difference between following a guideline and understanding why it exists. The crew on the surface understands why. They are living inside the reason. And that understanding produces a relationship with the planet that no Earth-based document could have specified in advance. A relationship built on the direct experience of depending on something you did not build. Something older than any human institution. Something that will be here long after the settlement has grown into whatever it becomes. The biology question does not resolve cleanly. Science rarely does. And this particular question is the hardest one in the history of science. The organic compound anomalies in the soil, flagged by the probes and confirmed by the surface team, are subjected to increasingly sophisticated analysis over years. New instruments are fabricated that allow more precise characterization of the molecular structures in question. Controlled experiments are run, attempting to replicate the compounds through known abiotic synthesis pathways under conditions that approximate the planet's surface environment. Some of them can be replicated abiologically. Some of them cannot. The ones that cannot be replicated through any known abiotic pathway become the focus of intense scientific attention. The debate inside the settlement science team is intense and respectful and ongoing. Is this the remnant chemistry of a biology that existed billions of years ago and is now extinct? Is it the signature of something that still exists, deep in the subsurface water, far below the depth that current drilling operations have reached? Is it a completely novel chemical phenomenon, something that happens under the specific radiation environment of a red dwarf star, that resembles biology to human eyes without actually being biology? The settlement does not have enough evidence to decide. They continue gathering evidence. They drill deeper. They refine their instruments. They think carefully. And they do not claim certainty they do not have. This is one of the most important inheritances from the journey. 300 years of living, where the cost of error is survival level, has refined the crew's epistemic practices to a standard that would impress any scientific institution on Earth. They know what they know. They know what they do not know. They do not confuse the two. And they report both categories with equal precision. In year 6, children are born in the settlement. The first human beings whose birthplace, in any permanent record, is listed as Proxima Centauri b. Not the ship. Not a transit. A planet. The births are attended by the full capability of the settlement's medical facility. The infants are healthy. They are placed in a nursery module with carefully controlled radiation shielding, filtered air, temperature management, and lighting calibrated to support healthy infant development. And they grow, faster than feels possible to the older crew members who watch them, because children grow on their own schedule. These children, as they grow, look out through the habitat viewports at a landscape that their parents and grandparents see as alien. Rock and regolith, and the dim red light of a sun that does not move. In the middle distance, the instruments and structures of the settlement. Beyond that, the Terminator. For these children, none of it is alien. It is just where they are from. It is the sky they were born under. The only sun they have ever known. And watching them look at it with complete, casual familiarity, the older crew members feel something that requires more than one emotion to describe. The feeling of having done something that cannot be undone. The feeling of a chapter ending and a new one beginning that no individual life can span both sides of. The people who remember the ship are watching the first people who will never know it. And that gap, 4 light years wide and 300 years deep, is also just a room with children in it, looking out. The question of what the settlement owes to the people who will be born in it, and what those future people owe to the settlement, is not theoretical. It is immediate. Because people are being born in the settlement right now, in year 6 and year 7 and year 8. Children who did not choose to be here, who did not volunteer, whose consent was not asked and could not be asked. This is the same philosophical problem that haunted the generation ship from the beginning. Every generation born in transit was born into a mission they never agreed to. The founding generation chose. Everyone after them was born into the choice their ancestors made. Now, on the surface of Proxima Centauri b, the same dynamic continues. But with a new dimension, because the children born in the settlement are not being born into a journey. They are being born into a permanent situation. This is not transit. This is home. This is where they are going to live and work and have children of their own. And what that home is, what it offers, what it demands, what it can and cannot provide, is going to shape their entire lives. The founding generation of the settlement has an extraordinary responsibility, not just to survive, not just to build infrastructure, but to build something worth being born into, something that offers the children who are growing up here more than just survival, something that offers meaning, opportunity, the ability to contribute, the ability to change things, the ability to have a life that is genuinely theirs, rather than just a continuation of the mission that was decided for them generations ago. This is harder than building a water processing facility, harder than establishing agricultural capacity, harder than solving any specific engineering problem. Because it is not a problem you solve and then move on from. It is a condition you have to maintain continuously, a culture you have to tend, a community you have to nurture. And the founding generation of the settlement is doing this work, this most important work, in parallel with everything else, in the spaces between technical problems, in the conversations at the end of the workday, in the decisions they make about how to teach the children, what stories to tell them, what values to model, what kind of community to be. It is not glamorous. It is not the part of the story that gets told in headlines. But it is the most important part. Because you can build perfect systems and still fail if the people inside them have nothing to live for. And you can build imperfect systems and succeed if the people inside them are committed to each other and to something larger than themselves. In year 8, a signal arrives from Earth. Not a new signal. A response. The settlement's arrival broadcast, sent in the first days after orbital insertion, traveled 4.24 years across the interstellar medium, arrived on Earth, was received. And 8.5 years after the settlement sent it, the reply is here. Multiple signals, in fact. Because Earth, having received the arrival message and understood the communication mathematics, sent not one response, but a compressed archive of responses. Hundreds of them. From scientific institutions, from government agencies, from individuals who had no official connection to the mission, but who, when they heard that a generation ship had arrived at another star system, sat down and recorded something they wanted to say. The settlement's crew listens to these messages over weeks. The messages are from people on Earth who do not know what the settlement looks like now, who are responding to the message sent 8.5 years ago, before the first landing was even made. Earth is 8.5 years behind. It will always be at least 8.5 years behind. The messages are celebratory, moved. Some are from scientists who spent their careers working on questions directly relevant to what the settlement is now doing, who have realized they will likely never receive the answers to those questions, sending messages into a future they will not live to see. The crew of the settlement understands this feeling exactly. They have been living with it since before they were born. The settlement composes its response carefully, because a response that took 8.5 years to provoke is worth careful composition. It includes everything. Every data file from the first years of operations, the water analysis, the soil chemistry, the biosignature debate, the agricultural progress, the medical records, the technical specifications of every system they have built, and a video archive. Every moment that was recorded from the first orbital survey onward, the first landing, the first step, the first surface sample, the first night in the surface habitat, the first cup of locally processed water, the first harvest from the agricultural beds. the first children born on the planet's surface. The children, now old enough to understand what they are doing, are invited to record messages of their own. They do. They talk about what they had for lunch. They describe the color of the sky. They talk about the sun that never moves, and how they do not think that is strange at all because it has never been different, and this is just what the sun does. They say, hello. And 4.24 years later, on a planet orbiting a yellow star, someone receives a child's voice from another star system. A child who thinks a sun that never moves is perfectly normal. A child whose home is a place no human being has ever been before. And everything that person knows about what it means to be human gets, very quietly, very permanently, a little bit larger. There is also the matter of what the settlement means for Earth, not just what it means to the people on the planet, what it means to the 8 billion people who stayed behind. The signal carrying the news of arrival reaches Earth 4.24 years after the ship achieves orbit. When it does, the response is not simple. It is not pure celebration, though there is celebration. It is not pure grief, though there is that too. It is something more complicated. The knowledge that human beings are alive at another star does something to the species that is hard to articulate. It changes the frame. Not immediately. Not in a way that most people feel in their daily lives, but at the level of what humanity understands itself to be. For the entire history of the species, every human being who ever lived existed on Earth. Even the people who went to the moon came back. Even the people who would eventually go to Mars were still in the solar system. The same star. The same cosmic neighborhood. One species, one planet, one solar system, and now that is no longer true. There are human beings at another star, not waiting for a ship, not in transit. There, living there, working there, having children there. And the children who are born there will know the settlement as their home, the way the people on Earth know Earth as their home. The species has branched, not metaphorically, literally. There are now two distinct populations of human beings, separated by 4.24 light-years, with a communication lag that makes real-time coordination impossible, with cultural developments that are already diverging and will continue to diverge over generations, with biological adaptations that may, over very long timescales, trend in different directions as each population responds to its specific environment. This is the beginning of something that has no human precedent. The beginning of a genuinely multistellar human species. And on Earth, the people who receive the news of arrival and absorb its implications are the first generation to live with the knowledge that this is what they are. Not a single planet species. Not even a single system species. Something larger. Something that spans, for the first time, the distance between stars. And that knowledge changes the way they look at the stars. Not just Proxima Centauri. All of them. The sky is no longer an unbroken frontier. One star in it has a flag, so to speak. One point of light in the night sky is now a place where human beings are going to work tomorrow morning. And looking up at the rest, knowing that is possible, makes the universe feel different. Not smaller. The universe is not smaller, but more accessible, more real, more the kind of place that things can happen in, rather than just a backdrop that things happen in front of. It is a profound shift. And it happens 4 years after the ship arrives, when the signal reaches Earth, and someone looks up at the sky and knows. The settlement in its 10th year looks nothing like the installation that the first landing crew assembled. More modules, deeper tunnels, a more extensive water network feeding the growing modules, the habitat life support systems, and the fabrication facility. Agricultural capacity that now provides the majority of the settlement's calories, with the remaining stored supplies being conserved as strategic reserve rather than daily nutrition. A fabrication facility that can produce the majority of replacement parts and new equipment without depending on components from the ship, which no longer exists in any recognizable form. A population that has grown through births to a number meaningfully larger than the ship's population at the time of arrival. Because the ship, after 300 years of careful population management, arrived with a crew sized for the mathematics of genetic diversity and life support capacity. On a planet with resources, those constraints change. The settlement can support more people. More people means more skills, more labor, more redundancy in expertise. More people means a faster rate of capability development. And a faster rate of capability development means the gap between where they are and where they need to be closes faster. This is the fundamental change that arrival brings. The ship was constrained, brilliant, meticulously maintained, keeping everyone alive for 300 years through extraordinary collective effort, but closed. Finite resources. Hard limits on population. Hard limits on growth. The planet is not closed. It is not infinite, but it is orders of magnitude larger than any vessel could be. And for the first time in 300 years, the crew is not managing scarcity against a ceiling. They are managing growth. The feeling is described in the oral histories recorded during this period as disorienting, not frightening, not uncomfortable, disorienting, disorienting. Like a fundamental parameter of reality has changed, and the people shaped by the old parameter have to recalibrate every assumption they have ever made. They were born to manage limits. They were raised to work within hard constraints. And now the constraints are growing outward, and they do not quite know what to do with that. So they do what they always do. They adapt. They set new targets. They build toward them. And the work continues. The governance of the settlement in its early years is a direct inheritance from the ship's governance, but it does not function identically. On the ship, governance was shaped by the absolute necessity of maintaining life support. The hierarchical structures that emerged over 300 years were always, ultimately, structures in service of the machine. The ship's chief engineer had genuine authority, not because of ideology, but because if the life support failed, everyone went with it. The medical director's decisions about population health were not suggestions. They were operational requirements. The agricultural director's output targets were survival math, not aspirations. Power on the ship was always, in the end, a function of proximity to survival systems. The planet changes this. Not immediately. Not in the first year. But over time, because the planet is not a machine. The planet does not fail if a single person makes a bad decision. The planet has been running its own systems for 4 billion years without any governance structure at all. And that difference between a closed mechanical system where every node matters and an open planetary environment where redundancy is geological and atmospheric and climatic changes the relationship between authority and survival in ways that take a generation to fully manifest. The people who arrive at Proxima Centauri b are conditioned by 3 centuries of living in a place where governance errors could be fatal. where the wrong decision about resource allocation could cascade into a life support failure, where social conflict, if it escalated to violence, could damage systems that kept everyone alive. They are conditioned to take governance seriously, profoundly seriously, more seriously than any political culture on earth, where the consequences of bad governance are serious but rarely instantaneous and universal. And they bring that seriousness to the surface settlement. But they also bring the specific models of governance that emerged from 300 years of ship life. Models that were shaped by the ship's particular constraints, by the particular crises that occurred and how they were resolved, by the particular personalities that dominated at different periods in the journey. Some of those models translate well to surface settlement life. Some do not. And figuring out which is which, while simultaneously managing a settlement that needs constant attention, is the governance challenge of the early surface years. The settlement's first formal governance document is drafted in year 2, not imposed from the mission protocols, negotiated by representatives of the surface crew. It is a founding document, the first time in the history of this crew that governance is designed by people who will actually live under it, on the ground they are trying to govern. The discussions are long, sometimes contentious. There are disagreements about how much authority technical experts should have versus elected representatives, about what rights the settlement owes individuals, about what responsibilities individuals owe the settlement, about how to handle disputes, how to manage resource allocation, how to balance the needs of the current population against the needs of future generations who will inherit whatever decisions are made now. The debates, echo debates, that humans have been having for thousands of years on Earth, but they are happening in a context that has never existed before. On a planet orbiting a star 4 light-years from Earth, by people whose grandparents were born in a machine between stars, with the knowledge that no external authority exists to resolve disputes they cannot resolve themselves. The founding document that emerges from these discussions is not perfect. No founding document ever is. But it is real. It is theirs, written by the people who will live under it. For the first time in 300 years, the governance of this community is not inherited from Earth or adapted from a ship's operational manual. It is made here, on this planet, by these people. And that matters more than the specific content of any individual provision. It is the first act of self-governance in the history of interstellar civilization. The biology question, the one about whether Proxima Centauri b has life, reaches a turning point in year 12. The deep drilling operation that was planned for year 8 but delayed by equipment and geological complications finally reaches the deeper subsurface water reservoir at 60 meters depth. The samples from this depth are different from everything above. Different in ways that the surface chemistry team immediately recognizes as significant. The organic compound anomalies are not just present at this depth. They are concentrated, denser, more complex. And in several samples, there are structures, not cells in the sense Earth biology defines them. Not the lipid bilayer membranes, the protein complexes, the organelles that Earth biology has used for 3.5 billion years, but structures, regular, repeating, bounded structures that are not the product of any crystal formation or mineral deposition process the crew can model. Structures that appear to maintain an interior composition different from their exterior environment. Structures that, under certain analytical conditions, appear to respond to changes in their environment in ways that directed, purposeful chemistry does not produce. The science team calls an emergency meeting. They share everything, every data point, every analysis, every uncertainty. And they argue for 3 days about what they are looking at. At the end of those 3 days, they have not reached certainty. They are nowhere near certainty. Certainty in this situation may not be achievable with the instruments they have, but they have reached a consensus. What they are looking at is consistent with life. It is consistent with a microbial ecosystem adapted to the deep subsurface environment of Proxima Centauri b, a biology built on chemistry that is not Earth chemistry, using molecular machinery that does not correspond to anything in Earth's biological record, but organized, purposeful, bounded, responsive, alive, possibly alive, probably alive. The settlement has a planet-wide communication system. The science team's report goes to every crew member simultaneously, and for a few hours, the settlement goes very quiet. Not because people are afraid, because they understand what they are looking at. They are potentially the first people in human history to encounter life that did not originate on Earth. Not intelligence. Not complexity. Not anything you could have a conversation with. But life. The same category of thing as every organism that has ever existed on Earth. From the first replicating molecules to every tree and bird and bacterium and human being who has ever lived. The thing that turns chemistry into something else. Something organized. Something that persists. Something that copies itself and adapts and fills the available space. Here, on this world. At 60 meters under the surface. In pockets of mineralized water lit by geothermal heat rather than by any star. The science team's report is transmitted to Earth immediately. It will arrive in 4.24 years. By then, it may be more certain or less certain, depending on what the follow-up analysis reveals. But it goes out. Because this is not information you hold. This is information that belongs to the species. And then, the settlement returns to work. Because whether or not the structures in those deep samples are life, the settlement still needs water processed and crops growing and modules maintained. The universe made an extraordinary thing possible. But the extraordinary thing does not stop time. And time, on Proxima Centauri b, keeps passing. And the work keeps needing to be done. There is a moment from the mission records of year 11 that stays with you. A young woman, born on the ship, but old enough to remember its corridors clearly, is conducting a geological survey at a site several miles from the main settlement complex. She is alone, accompanied only by a survey drone and the continuous telemetry link to the operations center. She has found a rock formation that is unusual, a cluster of crystal structures embedded in the regolith, formed by a process she does not immediately recognize. She crouches down to examine them, and as she does, Proxima Centauri passes behind a thin cloud layer in the atmosphere. Just for a moment, the light changes. The way light changes when a cloud covers the sun, something every human who has ever lived on Earth has experienced 1,000 times without noticing. Something she has never experienced before. The light on the crystal formation in front of her changes. The crystals catch the diffused light differently than they catch the direct light. And for a moment, from a certain angle, in that altered quality of illumination, the crystal formation looks almost like something she has seen in images of Earth. Not exactly like anything specific, but similar in the way that natural structures can sometimes look similar across vast distances of space and time. She sits with this for a moment. On the surface of a planet orbiting Proxima Centauri, looking at something that looks, just a little, like home. A home she was born too late to ever see. A home that is 4.24 light years from where she is sitting. A home that, for the first time in the history of her species, is no longer the only place where human beings live. And she records her notes on the crystal formation, the coordinates, the estimated size, the surface crystallography, the likely formation mechanism, a thorough, precise entry in the geological survey log. And then she continues the survey. And she does not mention, in those notes, what the altered light made her think of. Some things do not need to go in the log. Some things are just yours. And the light comes back as the clouds pass. And Proxima Centauri sits again, fixed and red and motionless in its permanent place. And she stands up and keeps working. Consider what it means to be the generation that arrives, not the generation that left. Not the generations born in transit, who grew up with the journey as the context of their lives, who understood their existence as movement towards something. The generation that arrives. You have spent your entire life being told that your purpose is to carry the mission forward. That what you do matters because of what your descendants will be able to do. That you are a link in a chain. That your life is, in the deepest sense, for something beyond itself. This is not a comfortable thing to be told. But it is also, if you receive it the right way, one of the most meaningful things a person can be given. A sense of purpose that extends beyond the individual lifespan. A reason to care about consequences that will play out long after you are gone. And then you arrive. And the chain becomes something else. Not a chain that is carrying you forward to a destination. A chain that has deposited you at one. And now the question changes. Now, the question is not, how do we carry this forward? Now, the question is, what do we do here? What does it mean to stop traveling and start living? What does it mean when the destination becomes the starting point? This is existential in the literal sense. It is a question about the meaning of existence, not abstractly. Not philosophically. Concretely. What is your life for, when the thing your life was always defined in relation to, the journey, is over? The arrival generation finds different answers to this. Some of them find the transition liberating. The focus shifts from survival of the mission to survival of the community. From maintaining a vehicle to building a civilization. That shift is energizing. It opens possibilities that the ship's constraints never allowed. Other crew members find the transition harder. They are people whose identity was built around the journey, who understood themselves as travelers, as people in motion. And now they are not in motion. They are here. And here is an alien planet with a fixed red sun and thin air and deep subsurface water full of unusual chemistry, and it is going to be their home. Not a waypoint. Not a transit. Home. And learning to feel that, to actually feel it, rather than just know it intellectually, takes time. For some crew members, it takes years. For a few, it may never fully happen. They will always feel, on some level, like travelers who have stopped. Like people waiting for the next leg of a journey that never comes. And the community around them holds space for that. Because the community is built out of 300 years of holding space for each other through exactly the kinds of transitions that have no precedent. That is another thing the journey gave them. The capacity to be patient with each other. To understand that different people process the same event on different timelines. To not require everyone to feel the same thing at the same time. To hold together even when individuals are in very different places internally. This capacity, built in the crucible of interstellar travel, is one of the most important assets the settlement has. More important than any single technology. More important than any resource they extracted from the planet. The ability to hold together. Through the hardest transitions, on the other side of everything. Year 15. The settlement's population has reached a size that makes it, by the most generous historical definitions, a town. Not a large one. Not even a particularly comfortable one. But a place with enough people that you cannot personally know everyone in it. A place with enough complexity that governance decisions affect people differently depending on where they live, what work they do, what needs they have. A place where culture is emerging not as something designed, but as something that simply happens when enough people share a space long enough. Music. There is music in the settlement. Not earth music preserved in the archive. Music composed here, by people who were born here, or who came here and were changed by the experience of being here. Music that reflects the specific sonic environment of the settlement, the hum of the life support systems, the particular acoustic qualities of rock-walled tunnels, the way sound behaves in a pressurized habitat with specific atmospheric composition. Music that sounds unlike anything on Earth. Not because the composers were trying to be different, but because they are different. Because they live in a different place, under a different star, with a different sky outside their window, and a different geology beneath their feet, and a different biology, possibly 60 meters below the floor. Stories. There are stories in the settlement that did not come from Earth. Not Earth stories, adapted to new contexts. Stories that could not have originated anywhere else. Stories about the Terminator, the permanent boundary between day and night that defines the geography of their world. Stories about the sun that does not move, and what it means when the one thing you can always navigate by is always in exactly the same place. Stories about the deep water and what might be in it, and what it means to share a world with something you do not fully understand. Stories about the ship. Always stories about the ship, because the ship is their creation myth, their origin story, the thing that made them possible. And like all creation myths, it is growing, gaining weight and symbolism that the actual records do not fully support. The founders, the original crew who left Earth, are becoming legends. Not because anyone is deliberately mythologizing them, but because that is what happens to the people who made the impossible possible. They become larger than the records. They become the answer to the question, where did we come from? And the children growing up in the settlement absorb these stories, the way children have always absorbed origin stories, with a seriousness that adults sometimes lose. With the sense that these stories are not just history, but explanation. Explanation of who they are. Why they are here. What they are supposed to do. And what they find when they look at the stories is something that was always true, but is now undeniable. They are the answer to a question their ancestors asked. They are the reason the ship was built and the journey was made. They are what 14 generations of sacrifice was pointing toward. And knowing that, Really knowing it changes how they approach the work. Not with the weight of obligation, exactly. With something lighter. With a sense that what they do here matters not just to them, but to the long chain of people who made it possible, and to the long chain of people who will come after, who will build on what they build, who will inherit what they create, who will ask their own questions, look at their own sky, and do things that the current generation cannot yet imagine. That is what it means to arrive, to be the answer, and also to be the beginning of the next question. What happens when a generation ship finally reaches its destination is not a single event. It is not a landing, not a first breath of alien air, not a flag planted in the regolith, not the discovery of water or the first harvest from alien amended soil or the first child born on the surface. Those things all happen. Each of them is extraordinary. Each of them represents a threshold that no human being had crossed before. But none of them is the answer to the question. The answer is, everything begins again. From the very beginning. All of the work of establishing a human presence. All of the engineering and biology and agriculture and medicine and governance and psychology that it takes to keep people alive and functional and sane in an environment that is not built for them. All of it starts over. Except harder, because the ship, for all its constraints, was designed for people. Every system in it was built to support human survival. The planet was designed by 4 billion years of geology and chemistry and stellar physics, with no consideration for human needs. And the people who arrive on it have to figure that out, one problem at a time, while simultaneously figuring out how to live there. There is no moment of completion. No moment when you can say, "We have arrived. The hard part is over." The hard part is permanent. It just changes form. And the people who choose to face that, who were born to face it, who were raised in the tradition of facing it, who carry 300 years of institutional knowledge about how to solve problems that no human has ever solved before. Those people are doing something that has no precedent in any human culture. They are the first people from Earth to live at another star. And they are, in the most literal sense, building the future. Not dreaming about it. Not planning for it from the safe distance of a home planet. Not pointing at it and saying, someone should go there. Building it with their hands. On a planet that did not ask for them. Under a sun that does not move. The ship that carried them is gone. Turned to building material and reactors and the infrastructure of a settlement that is slowly becoming something that future generations might call a civilization. The star the ship came from is a point of light that nobody in the settlement can pick out with the naked eye. The children born in the settlement look up at Proxima Centauri, the only sun they have ever known, and they think it is perfectly normal. They have no memory of the journey. They know it from records and stories, the way people on Earth know their distant ancestors. As history, as something that happened before them, by other people, for them. And someday, those children will have their own children. And those children will know the settlement as home. And the work will continue. And the settlement will grow. And one day, far in the future, it will be large enough and capable enough and confident enough that someone standing on its surface will look up at the night sky. And in the direction of a yellow star, 4 light years away, they will feel something we know very well. Curiosity. Distance. The faint, irresistible pull of somewhere else. and the cycle will begin again. That is the story of arrival. That is what happens when you get there. You find out that there is no getting there. There is only the work. And the work, it turns out, was always the point. Good night.